Hi everyone, in this presentation, I will explain how I applied responsible AI principles in my charm prediction model, particularly focusing on fairness, bias mitigation, and interpretability. First, I want to briefly describe the model I developed. I worked with a telecom customer charm database containing over 7,000 customer records and 21 features, including biometric information, service usage, and billing characteristics. So my goal was to build a machine learning classifier that could predict whether a customer is likely to charm. After processing the data, I trained the random forest classifier and evaluated its performance using the metrics such as accuracy, precision, and recall, F1 score, and the ROC AOC. So the model achieved an accuracy of about 0.78 and an ROC AUC of approximately 0.81, indicating that it performed responsibly well in distinguishing charms from non-charmers. However, performance alone is not sufficient when developing an AI system. Responsible AI requires that the models are fair, transparent, and accurate. Therefore, I incorporated several steps to ensure that my model aligns with the responsible AI principles. First, I address the fairness bias in the model. So you can see here, so one important concern in predictive model is the risk that certain diagrammatic groups may be unfairly treated due to the imbalanced data or hidden correlations. For example, variables may be unfairly treated due to imbalanced data or hidden correlations. So to mitigate this risk, I carefully review the features, include the data set, and ensure that the sensitive attributes were handled approximately during the processing. I also use the one-hot encoding represent categorical variables, which prevent the model from interpreting categories as the ordinary values. Additionally, I examined the distribution of the target variable and addressed the potential class imbalance by applying the class weight equal to balanced parameter in the random forest model. These adjustments ensure that the algorithm gives equal importance to both charm and non-charm classes, preventing the model from favoring the majority class. Another fairness-related step I took was ensuring data quality during uh, processing. For instance, the total charges variable initially contained missing values due to a formatting issue. I converted it into a numeric format and removed the few rows with missing values to prevent misleading patterns during training. Cleaning and validating data is a crucial step because mm, our incomplete data can predict unfair outcomes in machine learning models. So, in addition to fairness, responsible AI also emphasize transparency and interpretability. Complex machine learning models, such as random forests, can behave like the black boxes, meaning that it is difficult to understand how they arrive at specific predictions. To address this issue, I apply several interpretability techniques. First, I use the SHIP, SHAP, which stands uh, additive explanation. SHIP is a game theoretic approach that assign each feature's contribution value for prediction. Using SHIP, I guarantee the global feature importance plots that show which variables most strongly influence charm predictions. The analysis revealed that features such as customer tenure, internet service type, total charges, and the contract type were among the most important prediction of churn. Those goal explanation help stakeholders understand the overall behavior of the model. For example, the shape dependence plot showed that the customers with shorter tenure were more likely to churn, while longer tenure customers had a lower probability of leaving. Similarly, higher monthly charges were associated with an increased churn risk. So inside these are useful not only for model validation but also for the business decisions. Yeah, well, global explanation help us understand the model at a high level. Responsible AI also requires explanation at the individual level. For this proposal, I used the LAM, which stands for Local Interference Model Accurate Explanations. LAM explains individual predictions by approximating the complex model with a simpler interpretance model and around a specific instance. For example, I selected the customer in the test dataset who was predicted to charm and generated a LAM explanation. The model predicted a charm probability around 0.58 for the customer line. So uh, the line rating revealed that several factors contributed to this prediction, indicating a long-term contract. These factors push the prediction toward charm. Local explanations like this are extremely valuable for ethical decision making. They allow analysts, managers, or regulators to understand why a model made a particular prediction, if the prediction was based on irrelevant or sensitive attributes. It would immediately raise a red flag. Therefore, Lancet helps ensure that the model decisions remain transparent and adjustable. Another interpretive technique I used was partial dependence plot. Like, I think this plot visualizes how specific features affect the predicted outcome on average. For example, this partial dependence analysis showed that the trial probability tends to decrease as customer retention increases. This confirmed initiate business logic. Long-term customers are generally less likely to leave. Overall, combined shape, line, and partial dependence plots allowed me to examine the interaction sites like the chart provide a global feature importance and the feature interaction insights. And the line explains individual predictions and partial dependence plots illustrated the average relationship between features and interpretability. These interpretability techniques are critical for responsible AI because they transform the model from a black box into a transparent system. Decision makers can understand not only what the model predicts, but also why it makes those predictions. So in conclusion, I ensure that my model aligns with the responsible AI principles in several ways. First, I address the fairness by carefully processing data, handling missing values, encoding categorical features properly, and then medical class imbalance. Second, I improve interpretability by applying shape for global explanation line for the local explanations, and partial dependence plots understand feature effects. This method makes the model more transparent, accurate, and trustworthy. So ultimately, responsible AI is about building a system that are not only accurate but also for fair, and expandable and aligned with the ethical standards by incorporating fairness checks and the interpretability techniques. I was able to create a charm prediction model that supports responsible and informed decision making. So yeah, that's it. Thank you guys for the listening.